All right. Welcome to day 2 of Next Level Bug Hunting. Looks like we have just about everybody back. Still waiting on a couple. Looking through my roll really quick. Let's see, Diane. Sam.
No basement flooding this morning?
No, now there's just the big fans that are running, trying to dry it all out. So it's almost as fun, right?
And good morning, Ilya and Richard.
Looks like we're missing. There's Diane. Just give everybody one more minute to join, and then we'll go ahead and get started. There's Diane. There's Dustin. All right, so it looks like the only person we're missing is Dylan. But and we've got enough. We got quorum to actually get back and get started. At the end of the day yesterday, I asked everybody to look for open source projects that they wanted to review. Hopefully you've got some ideas. Keep thinking about that as we go through the rest of the checklist today, and then we jump into the review of VTM. So yeah, Ken and I are excited. Day 2 is always really fun, but we do have a fair bit of, we've got what, 3 more modules, I think, Ken, to get through. That's right.
Yeah. Yes, sir.
But to review, yesterday we went through, what did we go through? What were the 3 things? What were the 3 topics? There's Dylan.
Never forget.
Never forget. Yes. Remember the dad topics of InfoSec or AppSec, right? What did we go through? Does anyone remember? Or do we need to start all over? I know everybody wants to do that.
Starts with an A.
There we go. Sam's got it. Good job. Sam, Chris, Mike, you're all getting there. Good. Authentication, authorization, auditing. So AAA, we step back from specific vulnerabilities for a reason, because we want to understand all the security goings on of the code that we're looking at, not just very specific CVEs. Dustin, lots of IDOR. Yep, you're right. From an authorization perspective, IDOR is one of those fun ones. And I mean, honestly, like from what we find in applications nowadays, IDOR is probably top of the list. I see it in pretty much probably 90% of the applications that we test. There's at least one instance of it, if not, very prevalent. It feels a lot like what SQL injection was 15 years ago. It was every application that we had run into. So we just don't have a good solution for it because it's hard from a developer perspective. So, well, good. So since we've talked about IDOR, we've talked about AAA. We're going to talk about a few other topics that fall more under the kind of CIA triad: confidentiality, integrity, availability. But really, it's about source to sink traces. It's about identifying where data goes when it comes into the application. So the security decisions that are made around what's good data, what's bad data, accept lists versus deny lists, and how that's built into the application. And that's where we start with injection. Yeah, I mean, go ahead and name some types of injection. I know we've talked about SQL injection, but are there others that you've heard about in the past or you've dealt with? I mean, everybody's probably familiar with one. Command injection, good. XSS, Ilya, good. Yep, XSS is just HTML injection. Perfect. Sam, JSON, XML injection. Yeah, I've had a couple instances. I mean, both of those are pretty common, right? Be it with web services being used, SOAP services, all that kind of stuff. SQL injection, Diane. Yep, all good. I've actually seen recently a couple instances of CSV injection, right, where you start putting equal signs and different, CSV or spreadsheet commands into data, and it gets rendered into an Excel spreadsheet, and you can execute commands within that, depending on when the users actually download the Excel spreadsheet. So you've got to watch out for, as a developer, you have to watch out for what's coming into your application and decide what's good and what's bad. Some REST-based injection, is that so? Dustin, what do you mean by that? Just the JSON, like the calls to the RESTful service, or is it something else that you're talking about? Cool. So improper validation of the API calls on the application SID. Yeah, or on the application side. I think that's what it, yeah, there we go. It's like SID. I was trying to figure out if that was like an ID or something that I couldn't understand. Yeah, I mean, that's always an interesting one, right? Is that we've got RESTful interfaces that, React.js or SPA single page applications use, and the code or the data that's sent to those APIs isn't always scrubbed like it should be. Sweet, that's the server-side template in the injection that allows for RCE. LDAP injection, very interesting, right? Being able to run like LDAP calls based on a username, because they're just taking that string and passing it straight into an LDAP search. Mike, I've only seen that actually once in my career, and it was very early on. And it was honestly that exactly what I was describing, a login page where we would do this LDAP lookup, but you could log in as somebody else if you knew how to structure the call correctly. But it's not a super common one, you're right. But anytime you're using any backend, that's where the injection occurs. So let me see, the vulnerabilities, causes, yeah, input validation and output encoding. And there's multiple different types. We've talked about all that. The vulnerability classes that we're looking at here, SSRF is the new hotness, right? That's the new hipster vuln, right, Ken? But all these others come into play as well. XXE, XSS, so XML injection, SQL injection. Right now, injection is, I think it's number 1. Yep, in the top 10. I think it's going to slip a little bit. We don't see quite as much of it. Cross-site scripting is number 7, where that is really an injection vulnerability, but we call it out separately because, again, the OWASP top 10 is an awareness document. It's about making people aware of these vulnerabilities. It doesn't have a basis in, well, I mean, it will, right? We know the people that are designing the next version, but it doesn't really have a basis in true counts of number of vulnerabilities that are found. So those are the injection vulnerabilities that we'll be looking for. So it's basically anywhere that we're taking data from an untrusted source and passing it to a trusted entity on the back end, and not scrubbing that data for proper characters or proper doing proper validation on it. So these are a couple spot the bugs. What is the issue that we've got in both of these instances? Sudo to GDB. Yeah, that could be dangerous, Daniel, for sure. You have any ideas on the screen? Yeah. it's open. It's an open redirect for sure, right? So yeah, it's creating this this URL, and then it's taking the data directly from the user before it sends it along. The bottom one, there could be some, depends on what this URI kind relative actually does, but the initial thing that I'm looking at is a redirect URL. And we see this. Yeah, Ken, go ahead.
Sorry, no. Go ahead. Yeah. Sorry.
Ken's just moaning into the microphone. Ignore him. Yeah.
Well, no, I was trying to understand relative. I was actually looking up the is relative URL function to see if that's like something that's built in or if that's something that somebody wrote. And then just because a relative URL is relative to the application, so then you're talking about more of like a bypass, since you're talking about the path portion of the URL versus like the host and prefix, I assume, portion of the URL. So yeah, that's why I was looking at that and then trying to figure out how that has any impact on the second image you've got in there. Oh, I see. Oh my God, I'm an idiot. That is the is relative URL. Oh, I'm waking up still. I apologize. And some of these screenshots are new-ish, so I see it. It is the is relative URL, which is just creating a URI from the URL. Okay, cool.
Yeah.
Awesome.
Yep.
And then just sending it out. Perfect. Awesome. So that is relative URL check sucks. That's what basically the flaw is.
Yeah. The is relative URL.
We're learning together.
Just because it says is relative URL doesn't mean that it's really, it's performing it properly. And I mean, I know, Ken, you can speak to, URL redirects, because I know you guys deal with all the JavaScript or the / and I mean, I'm pretty sure you're dealing with redirects all the time.
Yeah.
Unless, correct me if I'm wrong.
No, yeah, and this is actually one of the biggest issues is that there is a difference between URL and URI. So when I see, basically, unless someone's just like saying, "Hey, give me a URL," and then I'll redirect you to that URL, which is like very obvious redirection. Most of the time when I see it, and it's not caught before it's pushed to like a master branch or a main branch, or like in a pull request to get merged in, it's because of the URI versus URL issue. So to cover that real quick, URI is all encompassing of many protocols or schemes. So HTTP, HTTPS, but also like FTP, SFTP, mail protocols. It's basically any protocol at all that's going to be handled. And that's very different from a URL. A URL is just the browser, right? Just the browser expectations. It's HTTP, HTTPS. We're not talking about every protocol. So what ends up happening, I guess why I'm bringing that up is, sometimes people will, one of the most prevalent things I see is when URI libraries are used versus URL libraries, there's that parsing issue where like the scheme can be JavaScript, right? So instead of it being like HTTPS, whatever, it'll be like JavaScript : something. And so that's sort of like a bypass where you can introduce not only redirects, but also XSS, right? Through that. So that's probably the most prevalent. Is just, and there's like other issues that go on with that, but primarily when I see problems, it's because people are using URI parsing libraries, not URL parsing libraries. I've done this myself. I've made that mistake myself. So.
Yep. Well, and that's part of the issue that we're looking at here is it's URI versus URL, as
right.
That's what they're depending upon. And then, we mix that up and the issues occur. But again, it goes back to the injection issue, right? Like we're taking redirect URL from the user, which is very common, right? How often do we see this in a URL as the parameter redirect or URL equals, and then some other URL that it then gets redirected to, depending on whatever conditions in the application are necessary. So, so from a a code review perspective, there's injection is a lot, right? There's a lot of stuff that can go wrong, and there's a lot of stuff to comb through. It really depends on the number of endpoints that we're looking at, and how disciplined the developers were in handling user input, right? And determining, trying to do something with it, checking for, bad characters or whatever they're doing, making sure that the address is formatted properly or the phone number is. It's easy to fall down, and it's easy to do this wrong. I mean, Google paid how much last year for cross-site scripting vulnerabilities? It was some insane, millions and millions of dollars that they've paid out for that through their bug bounty program. And it's all because developers, we still make mistakes, and it's a hard problem to solve because we may do it 95% of the time correctly, but that 5% is where we're getting caught out. In order to do the input validation checks and the injection checks, we've got to compile a list of the data sources, like where stuff is coming into the application. This is one area where automated tools are very helpful, whether that's SemGrep, whether that's some of the, the source code analysis or the SCA. No, I shouldn't say SCA, right? That's software composition analysis tool. The SAST, the static analysis tools are really good at identifying where input's coming into the application. The problem that they have is there's a lot of false positives, and sometimes they don't know about the different cleaning routines that are in the application. So there's still quite a bit of work that goes into this. But you start from that list of endpoints that you've created, you compile those data sources, you look for other ones. At times it's not always apparent, right? There's other places that we pull data from. If you think of HTML injection, think of cross-site scripting, it's not always apparent from a stored cross-site scripting perspective what is trusted and what is untrusted. So if I'm pulling data from the database and displaying that to the user, that could possibly be cross-site scripting if the data was uncontrolled at some point. Same thing goes for configuration files or templates, right? Depending on how those are built and what our trust level is with those sources, there may be injection in those resources or in those data sources. But we start with the routes we identified. That's what I'm calling out there: environmental variables, database calls, everything else that exists.
One thing I want to pause just real quick and explain too is that because this has come up in the past, and I have seen this for sure, where there will be so on the topic of injection, I've seen the more recent example I have from my work would be a method that was in a model where the method itself was performing essentially raw SQL-esque type stuff, but it was ultimately safe so yes, there was string concatenation or interpolation, one of the two. And so, yes, it would technically be vulnerable, except that in the two places that it was called, they did their job of validating the content that was coming in. However, do you report that? And I would say always, yes, absolutely report it as a weakness. There's no, just because, somebody's calling a method securely doesn't mean there won't be another method introduced later that calls that, or some functionality introduced later that calls the vulnerable method insecurely. And so I think it's valuable to report on that as we use defense in depth as our category for stuff like that, but it's creating it's a very much a layered approach. So I would report, I guess what I'm trying to say is, even if it's not called insecurely, but if it was called insecurely, it'd be vulnerable, point it out.
Yeah. And that is always the case, right? You talk about that API, those API input validation issues. Was it Dustin that you were talking through, right? Sometimes they don't always lead to a full-blown injection exploit, but anytime that there's some sort of a weakness there, it's being returned. So maybe it's being returned within JSON or within a JSON object. Like those HTML characters are dangerous. They probably need to be validated, or they need encoding flipped on them just because it's handled within a web application. Even though we are using React at that point, and it's probably okay, there's still dangerous things that can happen down the line. Our checklist is fairly easy on this, right? It's all input validated, and that's it. And I know that's kind of a simplistic discussion point there, but you've got to go through each of those endpoints, especially the sensitive ones, and see how input is validated and whether or not it is applied equally across the board. And this is where something like SEMGREP or your IDE searches come into play to actually see what's being handled properly. The other thing is, validation routines check for known good and cast to the proper data, or are they just building out some sort of a deny list, right? If they're looking at, hey, a greater than or less than, they're trying to build out their own deny list of bad HTML characters, that's usually an indication that there's a way around it. So you want to check those validation routines once you figure out what those are. It's not always super obvious what the validation routines are. It may be that they're depending on something like Django has their auto escaping that you can use that does auto escaping of HTML, or Microsoft's anti-XSS library. But you've got to figure out what that actually is to see whether or not it's been implemented properly. Most of the vulnerabilities that, like I said, most of the vulnerabilities that Google has paid out for their bug bounty program in the last couple of years have been because of XSS bypasses, has been because people have figured out ways to get around the validation routines that Google or the developers put in place. Cool. User is validated both on the client and the server. Security should not solely rely on client-side validations. We should know that at this point, right? If it's only on the React front end and it's not on the API backend, to Dustin's point, right? That's a bad thing. I did put, yeah, go ahead.
Also, CSP. If there's no CSP or super like permissive CSP that's constantly calling out to like marketing sites or whatever, analytics, and allowing all that JavaScript that's hosted somewhere else into your application or into someone's application, then yeah, that's a vulnerability. So definitely look for a CSP in the application. Call it out if it's not there. Make a stink about that, because honestly, input validation, output encoding is great, but at the end of the day, and it's part of our checks for sure. However, even if you do everything right, there's always the possibility of cross-site scripting. It's just one of those vulnerabilities that, it's like there could be an update to a library or a tweak here or there, and then now your site's vulnerable. So it's one of the hardest things to resolve. So CSP is like the #1 protection for cross-site scripting. That should be your primary protection.
Yeah, and I mean, we've got resources we can share with you guys on CSP as well. I know, GitHub's been on the forefront of that, and it was actually Neil. It's a friend that we've worked in the past. He works with Ken over there now too, who kind of pioneered some of that initial research into CSP. But if you want to kill that entire class of bugs on your site, that's the best way to go about it.
Yeah.
From a checklist perspective, data validation, both client side, server side, is it synchronized? Is it the same? Do those input validation routines use regular expressions? That's where we run into the problem of bypasses. Do they use accept or deny lists? And what bypasses exist? And then numeric input, are we actually casting things properly? Does it process input length? What happens when you send it 2,000 characters? Does it air out properly? Right. These are all just kind of typical validation issues that we see. We could talk about file input, right, as well during this. If we're accepting files, what sort of input is there? Are there any validation routines on those files themselves? How are they actually getting stored? Is there strong separation of force between data and commands? This is parameterized queries for SQL injection is the main thing that we're looking for here. Like, you're not using string concatenation to build SQL strings. You're actually using the built-in controls or the built-in functions for attaching data to a command, but in a separate object. Separation between data, clients, and scripts. Let's see. I don't know how much we need to talk. Is it checked for special characters before being passed? This would mainly be in string concatenation, right? Making sure that we're using some sort of a validation library before building those commands for third-party services. SSRF, server-side request forgery, is a huge one here, right? We're calling out to a separate site. If that URL is client controlled, as in the case of the redirect, what sort of data would we return, especially in an AWS or a cloud environment? Yeah, our forgotten HTTP request components. I have seen SQL injection in the referrer header for HTTP in the past because they were storing or they were logging to a database using string concatenation. So at times we forget that there are different components that are a little bit hidden. It's not always in the parameters that are being sent. It can be in HTTP headers or other places. Okay, so here's an example. Where's the bug? This is Django. Yep, Diane, SQL injection. Yep. Michael, you're right, not properly parameterized. For Django and especially Python, doing a search for this user objects.raw, that's probably a good indication that something has gone wrong because we shouldn't be looking it up that same way. Like we could do user objects.filter there and with the email and it would be properly escaped. Yep. Good job. Okay, let's see. All right, here's an example, SQL injection from Node.js. This one looks a little different, mainly because the query is user.findAll, which should be safe, but instead of using like properly, what we're doing is we're building a string within that query itself, right? So if you see that statement there on line 16, we're doing a % with request query.q, and we're passing in a string that we're allowing the user to control in an unparameterized fashion. Okay, so that's input validation. That brings us to output encoding. Yeah.
I want to briefly stop real quick and share my screen if you don't mind before we go any further, because I want to. We've talked about some of the traditional ways that injection happened, and I want to show some some variants to that. So, and also how we typically go about finding these. So. You may have not caught this yet, but in this slide, Seth talks about, log file. No, don't worry about it. It's fine. I have it up on mine anyways. So Seth has this up here where it says log files, where data is being stored and processed and all this. So I just want to show you. So again, my coworker and Seth and I have worked with John together. John Poulin had found a vulnerability in Rails. Basically, what would happen is, if you can see this, that show method, it's going to render a template, right? Basically, what it's saying is, I'm going to render some template that's in my file path for this application. So the expectations that you pass it the name of a template that exists in there, and you're going to be shown some HTML. What he did is he replaced that render params with the actual log file location. So what he noticed is when he didn't put in a parameter, he saw that the lookup was anywhere on the file system, right? Not just inside of the application root. So he put in the Etsy password, noticed that that render param would actually allow him to render the Etsy password as a file. Cool, all of that. But now we get into template injection, right? So these encoded values of, less than, percent equals, those ticks around ls in Ruby are system, that's the annotation for a system command. And those, the caret and the percent equals, and then the caret and the greater than, that actually denotes, hey, there's going to be some code that's going to be intermingled into the HTML template and execute that code when you render the HTML. Typically, you do that because you maybe you want to iterate through a loop to fill out like a table, or something like that. That's the typical reason that you would have not system code, but just code in general, Ruby code, running inside of a template, right? So what he did was he was like, oh, look, hey, I can go ahead and request a development log. The log that's, this would be production log or something else entirely if it was in production, but this is just running locally on his machine. So he's requesting the development log. And sure enough, now this is what happens in the log when he had sent a request that looked like this with the template language characters there, and then the ls. It was stored in the actual log file as part of the HTTP request he made. So when he requested the log and it was rendered as a template, the system code actually executed the ls command, and you can see gemfile.log, readme, all of that stuff. You get a full ls of that that point in where he's at on the file system. So when we talk about log sanitization, this is certainly something that is actually can happen. Again, going back to how nerdy auditing is, that's certainly true in this case. So, Seth, before I go on to the next thing, is there anything to add there?
No, I don't think so. Right. Okay. Yeah, I think we're good.
Sweet.
Yeah. It's just
actually I had to find that article. I couldn't find it in the old place. Then real quick, let's talk about SQL injection. So we said, hey, the common ways this happens, or the common ways you've read about in probably books and online: interpolation, string concatenation, all that normal SQL injection rather, type attack issues. So, however, there are other considerations outside of that. It's not just that somebody made a mistake, somebody didn't validate input, somebody didn't call something in a parameterized fashion. There are, believe it or not, ORMs with vulnerable methods built in, or at least if you call them in a specific way, they can be vulnerable. I like to always bring up this Rails SQLi. So it's rails-sqli.org. We can put that up into chat now. I put it in the Slack chat. Seth can put that in the Zoom chat. Anyways, when you go here, you'll notice at the top there are several versions of Rails: 3, 4, 5, and 6. That is because the active record library that allows you to interact with your database is different for each of one of those major versions, and has different ways that these vulnerabilities manifest. So it's actually pretty wild. If you look at something like Pluck, for instance, now Pluck is meant to just take some column name, right? So you could put in, users.pluck, I don't know, email address, and you would just get all of the email addresses for everybody in that user table. And totally valid use. However, if you give it user supplied data, it immediately becomes a SQL injectable type thing where you can do a select, you can override the intended query and just prefix the intended query with whatever raw SQL you want. So, well, to a degree, right? But that's pretty nasty. And if you go through here, you'll see all kinds of different uses where you wouldn't expect, but you wouldn't expect there to be a vulnerability, or you wouldn't expect if you called it in a certain way that it would be vulnerable. These methods would be vulnerable. And again, these are just built-in methods that someone created inside of Active Record to be the layer between you writing raw SQL queries and, just making it, something that's easily callable and just kind of there's a word I'm looking for, but I can't think of it. Convenience method is what I'm trying to say.
Yeah.
So anyways, my point being, you should look at the documentation always for the ORM that you're looking at, or the data store library you're looking at. Also look up any security related research in regards to that library. I know we talked about that yesterday, but it's no different here. If I'm going to go and find XSS in an application, one thing that is incredibly important, and I can show you like something real quick. Here's a good version of documentation. If I look up the Django template language and I just type something like escape, I'll usually be able to look for, like, if I search for a word like unencoded or unescaped or escaped or encoded inside of the documentation for a library, usually I can get down to a point where I'll find like ways to not escape, essentially, which is what you're going to see here in a second. So you see it say like by default in here, I'll blow that up. By default in Django, every template automatically escapes the output of every variable tag. Specifically, these 5 characters are escaped, right? Great documentation. Django is one of the better ones for that, I would say. However, then there's like the, if you don't want it to be auto escaped. And by the way, they do provide warnings in this documentation. It's not like they're naive about that. So you can do an individual variable by doing pipe safe on that variable. This is good. This is not good, right? And then you can just turn it off completely. Now, this is important because, when you see templates included in, like, say, a header or a footer, oftentimes, and this isn't just like a Django thing, this is just like a lot of times this just happens, where people will say, hey, these templates, I don't, they're going to have HTML data. I don't want them to be messed up when they're rendered. So go ahead and just turn off, auto escaping. And then inevitably somebody adds into that template, like user supplied input, like maybe, it's going to say hello first name. And then that gets put into the header, and then the auto escape is off, and then boom, you've got XSS. So it's important that you go and you look at the documentation for whatever you're, so in this case, there's 2 things: HTML template. You need to know like how those templates actually escape. And then also there's like I said, the library or the ORM or whatever type of library you're using to interact with your data store, which I'll get into in a second. But I wanted to finish this thought out with, here is a real life stupid templating thing that really made me mad and like caused me lots of heartburn because their documentation was terrible. And we had bounty submissions around this because, like, basically this documentation is not clear for .js temp. So on the note of paved paths, one of the reasons I love paved paths is that we have like checklists, we have automation, we have things that we can do like guardrails to keep us safe. When we do something like use a non-standard templating language that's kind of just like ad hoc and felt cool in the moment, you get documentation like this, which doesn't make any sense, right? That doesn't, nowhere, just so you know, if you go through this, there's nowhere it's going to really explain to you like how XSS could be introduced. But guess how XSS can be introduced? Absolutely here. So this says for interpolation, right? And this says for interpolation with encoding, right? It should actually say for interpolation without encoding / this is super unsafe / just know you're introducing XSS, because it's like, that's what that does. But instead it's very subtle: for interpolation interpolation with encoding. So this is safe and this is not safe, and it's not clear to you. There's also another one of these that's actually not, there is another operator you can use that I don't actually see listed here. And that operator, I think it's one of these where it's actually, it might be one of these operators and then just not like made clear anywhere in the documentation. But there's also another operator here that's vulnerable to XSS and it's not clear. But so my point is, like, even if you go and look at the documentation, it might make sense if you are unfamiliar and it's completely new to you to even just use these operators like in a local, like this is Node.js. So I could easily spin up a real quick little web server and test how each of these operators function when I provide them like JavaScript data, like from a JavaScript cheat sheet or XSS cheat sheet rather. And I could evaluate those operators and Now I do that. Now that's part of my process. Up until this was like a couple years ago, I did not do that. Now I do, because it's like, if I can, anyways. Just because, like, you can get bit even when you look at the documentation. And the last thing here is talking about Django ORM, or sorry, Django. I like to put in native query. Yeah, it doesn't matter what I type in. I could put in anything here. I could be like .NET Core native query, but I'm going to find how to do raw SQL queries. You can either call it native or raw. And I want to look at the documentation and find out, how like raw or native queries are performed. And the reason is because, and again, Django, credit to them, you should be careful when you write raw SQL. You're not protected. It's not doing any escaping. It's not doing any validation. You need to be careful. So when you do a review, I encourage you to go and look, and especially if it's a fully fledged out framework with its own, ORM or data store library baked in, go and look at the documentation, find out how raw queries are performed, and then search the code base or create some semgrep automation or something along those lines to look for it. So those are the sorry, Seth, that's the step back I just need to always, cover.
Yep. Yep. Nope. That's all incredibly relevant, right? Like, I mean, as we said yesterday, we spend a lot of time Googling and looking at framework documentation at the same time as we're studying the code. And as we're digging in, and this is exactly why, right? We'll do some of this up front during hey, we found out this is a framework, this is the database, this is the ORM that's being used for this application. Maybe we'll pull up the data and make a note of it that, okay, this is how raw queries are executed. But when we get to this section on injection is where we're actually looking in the code for those raw queries. We don't dive in at that exact moment. Like I said, it's pacing ourselves and making sure that we understand it before we dive into these portions. Let me see.
That brings up a good point, though, that we always like to, when we're at a point where we can kind of talk about what to take away and what to add into the methodology. Once again, you can never skip. It's never optional to do behavior profiling, tech stack. I mean, for this specific reason, for many reasons, but again, for in this case, we need to know, like, what's your tech stack so that we can know what vulnerable methods to look at. Now, if you are on a crunch time and like you've got, someone mentioned, I think yesterday, a 1 day to turnaround or 2 day turnaround on an assessment, do your upfront homework, learn the application, do all of that, figure out the tech stack. We're going to walk through it together. You're going to walk through it on your own. That's a no-brainer. But like, as you start to pull things out, you may decide, hey, look, a full source to sync on every route is not possible. I can't do this. I can't do that. I need to slim down my checklist. Totally fine. However, I would encourage you at this point to now introduce automation to find the dangerous methods that you are now aware of because you've done your homework on what you're going to be looking at. This is the point at where you can cut out some things and introduce others. So you'd be cutting out probably a large swath of your source to sync mapping, probably cutting out bits of your checklist. You'll get to what you can get to. But certainly now that you know what dangerous methods to look for, you would be doing a search and doing some validation. But you would also know how the context of the application looks. So you would have a better grasp of, if you're looking at like a .raw call, of whether or not that actually is something that's vulnerable. Yeah. So that's just to add to what you said, Seth.
Yep. Yeah, and it's it becomes, and it depends, right? Every time that we're looking at a code base, depending on how much time that we have, right? I run into this quite often because we're given, a code base and they've got, 500 API endpoints and, a couple 100,000 lines of code behind that. We have to concentrate and prioritize what's actually important, right? So identifying these kind of core functions, again, for input validation, for raw queries like ORM interactions, for, hey, like this is how we interact with third-party services like SSRF. I'm looking at those vulnerabilities from an injection perspective, and then identifying where the application is calling out rather than doing the source to sync to trace on every single item. So output encoding, this is very similar. Like before, we're sending data somewhere else. Are we properly encoding it in JSON or in XML like it should be to prevent those vulnerabilities from happening? Parameterized queries for SQL injection, that kind of thing. Output encoding checklist, parameterized queries. How is it being formatted before it's being sent back to the user? I mean, the user at the end of the day, like their browser is a sink. It's also a source, but when we respond to it, it is a sink. Does it use potentially dangerous functions? Ken talked about this. Identify the output encoding libraries that are used, make sure they're up to date and patched. And are there any weaknesses or blind spots in regular expressions? Okay. So this is EJS templates. Ken showed an example of the documentation for .js, which is a different templating language. This one, again, it's incredibly confusing. You'll see the less than % minus sign there. This is actually vulnerable to cross-site scripting. The encoding only happens when it's an equal sign instead of a minus sign after that. That is this is poor design from a templating perspective because it is so easy to bypass and it's so easy to make this mistake because we're just outputting data, right? And this was an example initially that EJS actually used for a long time before they started doing encoding with the equal sign. I do like React's idea of dangerously set inner HTML, right? Having a very long, very obvious way that escaping is turned off makes this safer from a development perspective and less likely to be bypassed. And the same thing goes, Ken showed Django the safe parameter, right? And you'll see that we're marking this one as safe here, but I feel like this is a little nebulous looking at it from a new developer's perspective, because part of me feels like if I mark this as safe, it's almost like, hey, I need this to be safe, as opposed to I trust the user.username. So it can kind of go both ways. I don't enjoy, or I don't necessarily agree with how they've put that together. I would rather see, unescaped or something like that's a little bit more obvious.
Well, in Rails, it's literally called HTML safe, .html safe, HTML underscore safe. So
yeah,
I
know it's bad. It's bad. Again, React, those guys did it right. Dangerously set inner HTML. Okay, there's a warning built into it. There's no warning here, right? It's just safe. I don't know. It's a pet peeve of mine. It's fine, right? Like once you know, but it's still a pet peeve of mine. All right, so that brings us to the injection exercise. We've still got a couple more modules to get through, Ken. So I don't know if we want to take tons of time on this. Let's do a single injection or build out a couple items for Skia Django. Let's not trace all the sources, even though there's not a lot to it. Pick out one of those, trace it, and identify all of the sources and sinks, and see if you can figure out what input validation and output encoding, if any, is going on for Skia Django. And then let's just do one for Behema. Let's not do 3 different sources to sinks, but let's see if we can identify one of the endpoints as data's coming in and where the data actually goes after that. Behema is a little bit more, it's a bigger beast. So, we may or may not actually identify how that is being, how the input validation output encoding is happening there, but we'll look at it shortly together. So do a couple Skia Django endpoints and do at least one Behema one. We'll take 12 minutes to do this. Do you think that's enough time, Ken? Or am I pushing too hard?
No, okay. That's fine. Yeah, I think we can go quick on the other 2, and then that'll leave us time to go do VTM before lunch. And if it's 4 hours into, yeah, we're good. Yeah, that's good.
Okay, good. All right, yep. Well, yeah, in that case, let's take 15 minutes. I think we're okay.
Yeah, we're good.
Yeah, I keep looking and forgetting I'm an hour ahead. So, Yeah, so let's take 15 minutes. So we'll come back 5 after the hour, but go ahead and build out those two. Take the time at Behemoth and see if we can figure out where input validation is happening and where output coding is happening, and we can identify more things from there in the discussion after. So 5 after the hour, go do both of these and ping us if you have questions. All right. All right. So first up, Skia Django. Injection checklist. We already had our list of endpoints from the previous uh, information gathering, the other previous phase that we conducted. First things first, ORM wise, like how are we retrieving data from the database? Does it look to be safe? Are we still looking at, is everyone still looking at Behemoth? Is that where we're at? We look at Skia Django. If we're looking for endpoints, we can find them in URLs, right? The intro URLs is probably what we're going for. But those are going to tie directly to specific views. So if we're creating a to-do, and this is where I'd be looking for input initially, is this create to-do, because we're dropping things in there. It looks like we've got cleaned data, this form.cleaned data, which is part of the to-do form. But something in there is actually doing some sort of cleaning. I'm not sure exactly what that ends up being, right?
So it looks like in the forms they would set what kind of field it is for that particular form, but it looks like specifically for text in the to do, it's just seeing that it's characters and sets a max length. So
there you go.
in other words, so the clean data would say yes, that's valid because it's characters and it's not more than this length, but it's I don't think it does any deeper check beyond that.
Yep. Yeah, I think you're right. Yeah, it looks like so. Technically, we could push dangerous data into it, and then the question becomes, okay, so this is the sink. We've created this, to do. It's got some dangerous HTML characters in there if we're looking for cross-site scripting, or we're looking for SQL injection. But let's see, the form creation, like how are we actually storing that? Yeah, we're just saving it out directly. But the to-do, yeah, it's built around that. So this is using the ORM kind of as expected, this creation of a new to-do item there, saving it out. We're setting the owner as well, but it's displayed back. That's where that would be my next question is, okay, what is this trace? What are the other sinks that I've identified here? And there's a couple different ones. There's the database, that sink, there's the user sink as it goes back, but there's also this updated to do, right? The logger sink. We've talked about log injection a little bit already. So, but there are some items there that could be of concern considering the username is coming out of is user controllable during signup. So let's look at the template as well. If I remember right, these are all done properly. Yep, exactly. Yeah, Dylan, it would have to be with the safe or auto escape would have to be off, right? So if we look at it here, okay, the form as as P, you're absolutely right. Like this is a create. Yeah, it looks like it's just taking that form and pushing it straight. And then what about the update, right? Let's take a look here. Because there's kind of multiple places where it's being shown. Yeah, so the form is being rendered with whatever is in there, but it's not necessarily like we're not disabling. We don't do a disable of auto escape unless it's disabled from base.html. And we can check because there's kind of a lot of places that we have to look when we start thinking about templates. If we include base.html and it's turned off here, it'll turn it off for subsequent templates as well. So it doesn't look like that's there. If we look for auto escape, yeah. But the only reason that we know to look for auto escape is because like we did that research up front, we know we're looking for safe, we know we're looking for auto escape. And we could search for those in the in the IDE as well, like looking to see if there's somewhere that maybe it shows up and it shouldn't be. This is the other place that I would look, like the list of to-dos when you've logged in. You'll see it says to-do text. There's no, pipe safe in there either. So I think we should be good as far as this goes. We have other issues that we have to deal with, but this should be good as far as HTML injection or SQL injection. I don't think there's a way to exploit it here. I think that's my initial.
Actually, could you clarify that for me? So you're saying that because I thought we would be looking for those indicators that say safe or that autoscaping's turned on. So you're saying, are you saying this is vulnerable or not vulnerable?
No, it's not vulnerable. Sorry, I was a little like, I talked around it there. It's not vulnerable because I don't see either of those indicators. Right, by default, the template injection is on. Or sorry, I said that wrong. By default, the auto escaping is on. You have to turn it off in Django, but we wouldn't know that
Okay,
unless,
yeah, that makes sense. Yeah, sorry, just got a little confused there with the wording. My bad.
Okay, Mike, that's an interesting discussion. If it's within a script context, would it be exploitable even with a, yes, it would be, because the safe, did you mean even without the safe? You probably did there, Mike. Yes, it would be, because you're writing directly into script that's already being executed. You would have to change up the escaping that's going on. By default, it's just HTML escaping that the Django templating engine does. There's other escaping that you would have to do. To prevent things like script injection or URL, like URL encoding. All of those other types of encoding aren't done by default. It's only HTML encoding. Right, so encoding, yeah. What are we seeing? Yep. Language syntax reference. So let's see, where's my auto escape here? Yeah, and that's exactly what it says. So it's HTML auto escaping. You can change the backend if you want to use Jinja templates or something else. You can do that, but most people within Django, they don't. Like it depends on what you're dealing with. But there are other encoding libraries that you can use, and other ways that you can actually do the auto escaping or the escaping of different intended destinations. All right, so that was Skia Django. What did we find out about Behemoth? Sounds like we kind of got through Skia Django all right. Is someone willing to tell us what they were able to find? Did anyone figure out what encoding or what input validation was going on with Behemoth? Yeah, so here, this is showing the to-dos. This is logger info. Okay. Did anyone get to Behemoth? Let's see. Maybe I should have started there. It doesn't sound like it. Okay. Yeah, we didn't give you a lot of time, and Behemoth's got it's a pretty huge, yeah. Angular sanitizing. Yep. Okay. Yeah, we would have to look that up, Richard, as far as what that actually means for sanitization on the and the SPA on the front end. Let's see about the other. On the server side, we've got, the app as things are coming in. Okay, there's the different routes. Let's just trace one of the routes together really quickly. So if we look at config routes, something that's accepting data or looks like it is accepting data. Inventory, stock, fiscal purchases. I mean, let's take a look at finance controller purchases and see what ends up going there, right? All right. Ken, do you want to do a little bit of his investigation here?
Yeah.
For a minute for Behemoth. It sounds like I've got. Sorry about this, guys. I've got a contractor that's asking a question. I've got to go answer it quick. So.
Actually, to be honest with you, I think given the time, I'd like to just move forward and go on to the next section, if you don't mind. So
yep.
I can start presenting, remotely while you're dealing with that.
Yeah. I'll be right back, Ken. If you want to just.
I'm going to request it, so just go ahead and.
Yep.
Yeah. All right. Cool. So let's see here. Going back to should be good. You know what? I may need to. Sorry, this has got a. There we go. All right. Cool. All right. So with cryptographic analysis, there are a few things obviously to talk about, but one of the main things I like to point out with cryptographic analysis section and with crypto in general is none of us on this call are likely cryptographic experts, meaning this course isn't going to be focused on, say, like crazy edge case nuances with cryptography. The best guidance is always, make sure people aren't rolling their own crypto. That's always a problem. Ensure that the libraries being used to perform cryptography are well vetted, well supported, lots of eyes on them. Ensure that you look at the documentation for cryptography functions to make sure that they're being used properly. As I mentioned yesterday, when JWT, again, I think it was the last year, it was discovered that when an algorithm's not put into most JWT libraries, doesn't matter the language, that it will default to no actual encryption or hashing algorithms at all. So that's the kind of the high level on where we're about to go. But in terms of what you see here with tooling, yes, most oftentimes tooling will both be great for that, but also the bane of your existence. So like MD5 and SHA-1 have valid use cases, not necessarily for security usage, but in terms of, like, I've seen MD5 used to literally just it was like to create a primary key or something like that. And it was like, for instance, taking a user identifying value, like just a numeric ID value, and just for some reason of interoperability, MD5ing it, just so, again, presumably that's like in some standard value, or there's no, I really honestly, like, I've seen weird times where MD5 is used for not security impacting features, and it's fine. Seen SHA-1 used again for it's not really for like security impacting. Now, I should say entropy on MD5 is not great, obviously. That's well known, but I've seen SHA-1 used for just a little bit of entropy being introduced, but not for any like sort of security related entropy, and just really benign use cases. So why I say that is sometimes you get like 2,000-3,000 results on MD5 and SHA-1, and then you're like, oh, great, I've got to validate all of that. My suggestion would be to not do that, and instead just ensure that you obviously, like we keep reiterating, have done your homework up front, that you have context on the application. I think first few glances will give you an idea of the usage there, but it's better to just point it out and summarize it as something like, in the test cases we looked at, it wasn't super vulnerable. However, just be aware that these algorithms are used, and I would maybe pass that information along for sure, but definitely I'm not going to go through and look at the scanner results of like 3,000 SHA-1 usage, pieces of usage. It just doesn't make sense. So tools are great, but they can also be a real problem and, muddy the waters. And I would, if it were me, I would save the cryptographic checklist bit, just like we did in this presentation, towards the end, right? Just because, like I said, that's usually not, you can find him. I'm not saying you're not going to find impactful vulns there, but I am going to say if you're using automation to discover some of this, which you should be, you may end up with a ton of results that you don't want to filter through with maybe say 48 hours left, or sorry, 16 hours left in your testing. There might be other places you can give some value. Code and routes that handle sensitive information. So yes, when you're dealing with passwords, tokens, any sort of sensitive data that you see here, credit card numbers. So honestly, credit card numbers are an interesting one. If you're seeing code that is processing credit card numbers in the raw, you're dealing with an application that's probably a financial application, because most people these days, they're not transmitting credit card numbers in the raw. Usually they're using some third-party service like Braintree to process credit card numbers. But in any case, where you see the most sensitive data, so when you've done your upfront profiling of the application and you figured out what data is stored in the application, this is where you then would you would start to introduce, hey, I know what types of the most sensitive data are in the application. So now I'm going to start tracing where they're actually used and look at how they're being saved and transmitted. Yeah, you can do an IDE search. I think it's also just fine to use semgrep. Totally fine to use that. The reason you see encrypt and decrypt is, or you can see encrypt, decrypt, hash, sign. Those are the types of keywords that you should be looking for when you perhaps create a semgrep rule or perform a search. Yeah. So, and this is really what it comes down to, is usually it's either there's a complete lack of encryption or hashing. I'm saying encryption, but I really mean encryption or hashing. Obviously encryption is a reversible value. Hashing is a not reversible value. Just real quick refresher on hashing versus encryption. And so when we see a complete lack of encryption or hashing with really sensitive data, that's a problem. I see this, believe it or not, where this is actually more often a problem is not necessarily in storage inside of databases these days anyways. A lot of times this actually occurs because there is some sort of resiliency plan, and the tooling that supports that is usually in-memory databases, so that if there's some failure, you have your in-memory database there to help you out, or sometimes it's just caching for speed purposes. Sometimes people put things on a pipeline, like a aqueduct style, Kafka style pipeline. And this is where you most often see a complete lack of encryption. Seems these days, especially in the frameworks I review, there's some built-in convenience methods to make encryption and hashing pretty easy as it comes to data, traditional data stores, database data stores. But again, when they're pushing into event-driven pipelines and things like that, and in-memory databases, this is where I see these flaws usually pop up. In terms of improper encryption, that could just be so for instance, where I talked about yesterday, how, and I see this in node applications more than anywhere else, is this reuse of a key. So a key should not be reused to generate cookies and then also used to say, validate webhook events, and then also used to say, HMAC sign something. But that happens like where the same key is used over and over again. So key reusage is a big one. Not having a strong algorithms, another, using a library just straight up improperly, using a library that's not well vetted. Those are all, like, honestly, the most common that I see issues with improper encryption, just from a very practical standpoint. And then in terms of insecure token generation randomness, where I see this the most is usually when people try to create tokens that are friendly for people to put in on mobile devices. Usually the justification is, well, we only did a 6 or 8 token limit, is because it was just easier for people to look at and then copy and paste over. That's not a good reason to create insecure tokens. Your token guidance is something that could be widely debated, and it's why we don't get into such great detail here. But it's one of those things where you typically know it when you see it. When you see like a short token value, especially if it's a library that they're like kind of creating themselves, or in the case where there are sometimes you'll see like random number generator libraries, but that's not a security random number generating library, right? It's not security well vetted. It's not meant for that. People just call it, it's like technically random, but the entropy is really not that high. It's not using a true secure random generation function. That's where we see, so those are the types of issues we see, is like length, an insecure library or just library that's being used for security purposes. It's not meant for security purposes. Seth, is there anything to add on that one?
Yeah, I was just going to say the other thing that I see coming out from an external perspective is key handling, right? So, and that falls kind of under cryptographic analysis and also configuration analysis. But a lack of protection for cryptographic keys is very common as well, where, whether it's like hard coded, pushed out with mobile applications, that they include private keys in mobile applications or in, React applications. It just gets built as part of that kind of like that CI/CD pipeline, process, that things don't get stripped properly. I think Ken mentioned it as far as improper encryption, but anytime that somebody is trying to implement it themselves, or insecure token generation, is usually when we see problems, right? If the only thing that prevents someone from breaking your encryption is knowledge of the algorithm, you're doing it wrong, right? That's what I want to boil down to. Or that's what it boils down to. And, if you remember, Ken, when we worked with that large retailer, right, that was one of the things that we looked at, as they were trying to push out this encryption library to all of the stores. And the encryption library ended up, it would generate tokens on like an hourly basis, but all of the different instances would generate the same token. So the only thing that was being used to generate the token, if you had the algorithm, was the date and the hour, right? That was it. That was the only thing that you needed to guess in order to generate a proper token to decrypt values. So it wasn't a secure library. Like we disabused them of that notion pretty quickly. But it's interesting whenever people try to implement their own. And I get that developers are smart, but the developers are not the crypto geeks, and they don't understand it to that same level. As much as they'd like to think they are, they just aren't.
Yeah, no, crypto is its own field altogether. And I had kind of touched upon that. But yeah, that's why we're not giving you explicit advice. Instead, we're giving you sort of high levels, because it's very contextual in each use case, but there's some general guidelines. Some of the general guidelines we're walking through now that you can use to kind of get I like to call it a code smell, or a smell, or, you can kind of just tell that there's something that needs to be investigated. But based off of especially anytime you see somebody roll their own crypto, that's just, no matter how smart they think they are, or no matter how smart they are, it doesn't matter. If you don't do this professionally and work amongst a team and create standards for cryptography, you're not going to do it right. It's just the reality.
Yep. So that, yeah, those will be the things that we'll be looking for, right? Standard encryption. So the checklist, you're going to look for standard encryption libraries, what's being used for both hashing and encryption. You're going to look at the strength of the implemented ciphers, like what sort of algorithms they have chosen to use, and whether or not those are hard coded. Ken already referred to JWTs, and the algorithms that are used for that. That's becoming more common lately. Making sure that that's using the right, like AES 256 or whatever, like algorithm is actually recommended instead of the null cipher, right? And then, I mean, all these are just recommendations. You can look at NIST for further like best practice recommendations, and you'll probably want to do that. It just depends on the source code that you're looking at and how critical this is, and like what's actually being implemented in code. Private keys, passwords, secrets, are they properly protected? Obviously, we're going to be looking at that. Okay, so let's do a Skia Django crypto checklist. We want to know how passwords, specifically how passwords are stored and tokens are generated. There'll be some indications in the code, but it's probably going to have to do with documentation. So this is for exercise B7, right? And then
I want to,
yeah, go ahead.
Before we get there, I do want to take a step back real quick, because we do need to just, like real quick, going back to the slide here. So it's not just our secrets properly protected, but it's our secrets properly stored somewhere, right? Like people ask us a lot of times about, I mean, this has always been something like, what do you advise for key storage? Yeah, an expensive HSM might be, because the reason I'm going down this road is you have to have rotation, right? Like on the secrets that you're using to perform, it doesn't matter, hashing, encryption, whatever, even if it's like what you're using to create sessions, at some point that value will need to be rotated. These values need to have the ability to be rotated, and you need to do it securely. And using like just an environment variable that you push up in, like, I don't know, some config or Puppet or something like that, that's not enough, right? You need to be connected to something secure. So there are, like, AWS and Azure, of course, they have HSMs, they have stuff that you can spend money on. Vault's a great option for that as well. We rely heavily on Vault, but you do need to have some rotation. And then again, like, this brings up the idea of keys and other sensitive, values used for security impacting functionality being stored in source code. You cannot. It should be obvious to everyone here that you should not be storing API keys, encryption keys, whatever it might be, in the source. But people still do it. So it's something to be on the lookout for, and it's part of this checklist. So key rotation, there's a third thing. So key rotation, secrets and tokens and such being stored in the source code. The last thing is when I talked about HMAC verification, there is one consideration that can throw it all off if you don't take it into account, and that's time skew. So you do want to account for time skew anytime you're relying upon some timestamp inside, and that happens very often with like an HMAC verification or HMAC signing. So in those cases, typically we don't go more than 5 to 10 minutes in our recommendations for time skew. I know this is an implementation detail, and it is, again, very contextual, and it is very, like, I'm sure that much smarter people than me could get into like the weeds on that, much smarter crypto people. But on the whole, I'd say account for about 5 to 10 minutes of time skew when you're dealing with this type of stuff. So anyways, Seth, I just want to make sure we covered that before we moved into the exercise.
Nope, that's great. Right. As far as private keys go, I mean, I think we've shown examples of that, right? And we'll see it pretty quickly in settings.py for Skia Django. But in addition to that, right, those commonly used secret keys are always pretty interesting to go and research, right? If you go on, if you do like some GitHub spelunking, you can actually find secret keys all over the place. And GitHub has some, they've implemented some utilities to notify people when like things like AWS keys get pushed into source code or into GitHub and other items as well. But we still see these secret keys being used in applications based off of templates, right? Like templated projects or new projects that people don't change those signing values. So you've got to be careful with those. Obviously, we're doing it wrong in Skia Django, but we'll take a look at that here shortly. So let's get to Beethoven. Let's build out a crypto checklist, the things that we think are concerning with the to-dos, like what should be encrypted, what shouldn't. Specifically, passwords are kind of the most secret thing there. The to-dos don't seem to be too much, don't seem to have too much data that we need to be worried about, but it depends on how the users would use them. So how are passwords stored and how are tokens generated? Let's look into that. We'll take 10 minutes on this and then maybe ask the same questions of Behemoth. What hashing is being used for passwords? Let's see if we can figure that out for Behemoth in the same exercise. So I'll ask both those questions. Should we just take 15 on this again, Ken, do you think?
Absolutely. Yeah.
Okay.
So that'd be 50 after the hour, roughly.
Yep.
We'll come back.
Yep. Okay, 50 after the hour. Let's jump back. So dive into Skia Django and Behemoth on the crypto side of things, and we'll talk about it when we return.
I'm going to go grab a snacky snack. I'll be right back.
Okay. All right.
Getting hungry. All right.